Alright, what's up everybody, this is Martin of X Forever and welcome to the 4th episode of Let's Make a PID Loop. In this episode, what I want to talk about is that as you've already set up your P control, which is basically the easiest control and the most basic control in your PID loop, I want you to get your hands onto actually starting to test it and starting to see how it can enhance your autonomous movement, which means I want this to become a very simple autonomous building block. And today, hopefully by the end of today, I'm going to show you how I actually use that. We still, in future episodes, we're still going to put heavy emphasis on integral and derivative to see how they basically act as a stabilizer and shock absorbers to increase our accuracy. But I really want you to start testing just with P if you want to, and that's what I'm going to show you. And there's one thing standing in between me moving on from just this theoretical knowledge to you actually seeing how it works is the timing condition, or the condition at which this while loop should end. Right now what this does is that it moves the robot 12 inches, and then the robot basically goes all the way to 12 inches, and then it either starts to oscillate or it stops there if your p-value, if your constant value is small enough. And then it doesn't do anything because the while loop never ends. It always calculates, which means that if you try to move the robot, the robot will try to keep itself at that position because of proportion. However, it never stops. And that will, we need to do multiple movements, so we need to stop this block. We need to stop this user function. We need to stop this while loop, which means this condition right there cannot be true. It needs to be something else. And I like to do something more like timing. And although there are a lot of timing methods that you can, use, I would still prefer you to look at my timing method, because after I finish it and after me explaining what it does, you might find it very helpful and useful. Although my programming might not be the neatest, but let's just take a look. It's this little method that worked very well for me in Skyrise, and I enjoy the simplicity of program-based movement. So what I'm doing right now is that I want to do something like this. After the robot enters, or after the robot almost hits the target, I know that when the error is small enough, for instance, when my error is 30, this is what I just typed. For instance, when my error is 30, that means when the actual distance from my robot to my actual target is about 0.3 inches. That's a very small zone. I want to start timing right there, and then I want to say that I want to time, for instance, 5 seconds, which means that after I enter that very small zone and then to the robot exit from its adjustment and oscillation, it's going to take exactly 5 seconds. And this is very useful, and you can see I just added a little parameter called wait time, and actually I'm going to change that to float wait time, and we are going to do something with it. And yes, let's just roll this way. So the way I do it, is that I do it with the timer, and the way I do it is that after I enter that zone, I somehow unlock a variable that used to lock the timer from starting to time, and then I use the timer to time exactly the time I put in here. So before we do that, let's make a trick I like to use. I don't know the official term, and I would like to learn that in my college computer science course, but right now I just call it somehow like a lock variable. You can I like to use everything in integers, but for the sake of professionalism, I will type the correct or the best variable here, which is bool. Let's call this timer lock. Timer bool. Let's call this timer bool. And first we wanna set it to true. Let's set it to true first. And then check out what I do right here. And just remember this right here. This thing right here still needs to be filled out, because all we care about is what sort of condition I put in right here, what sort of variable I manipulate, and finally I put a condition or a operation right there to make the while loop either become true or false as I desired, so that the loop can end and I can exit. And let's see. All right, let's start doing this. The way I do it is that I want to do it one way. I call this a one-way if statement, which means basically if you hit something, no matter that thing changes back or not, I'm going to eternally change the state of my variable. In this case, I'm going to eternally change the state of my timer bool from true to false once I hit the 30 target. And although I might oscillate, out of 30 if your loop is not tuned appropriately, that doesn't mean that I'm going to change the timer bool from false to true back. So that what I'm going to do is that just a simple if statement, very simple. If error is smaller than 30, I am going to change my timer bool. Excuse me, I gotta figure out why that happens. Always happens when I'm making video, and I never figured out. False. So timer bool, as long as if, no matter what, or no matter if you change back or not, as long as my error, as long as I first hit that zone, the state of this variable is gonna be eternally changed. And even though I exit that zone or whatever my error become is not going to change back again, and that's good, that's what we want. And then if I'm going to type this, and actually I apologize for not initializing or showing you how to initialize the timer. The way to initialize the timer is like exactly like this. Excuse me, I gotta look up the command. So yeah, I always have the most trouble with timer commands in Robot C, square brackets and parentheses, so I'm just making sure. So the way you clear a timer, you start a timer is hit clear timer, and then round parentheses, and then you hit the name of your timer, T1. So let's just say in Robot C there are 4 automatic background separate task counters, and the timer T1 is just the first timer. So in this case we're just going to use the first timer. And so how are we going to manipulate the trick right here? Right here, just follow up closely. This is the tricky part. If I'm going to type this, if timer bool, and then I'm going to type clear timer. T1. And then right here I have a wait time, so let's do while, excuse me, your timer, while, and we want to call the time from the timer, so let's go time, let's do time 1 is going to be fine, although I don't quite like it. Actually, excuse me, the time should be lowercase, time 1. I'm going to make sure too that's right. Time 1 T1 is smaller than my wait time. So how does this work? You might ask me. Yeah, it's very confusing. It's something I figured out on my own. I'm not sure whether it's a standard way or not, but this is the way I do it, and I'm going to explain it. Alright, so how does this work? First, when the robot is starting, the timer bool, and when I'm not entering when this is not triggered. This is basically like, when the robot is moving normally and this is not triggered, the timer bool is true. So this is always executed. So when I'm actually moving, every single time I run this loop, I clear the timer and then I check the timer I just cleared. What value does it have? About 0. If it has a drag, it's just a few milliseconds. I want to make sure that that is smaller than my wait time. If it's smaller than my wait time, the loop will keep running. In this case, yeah, every time I clear it, and then if I put an actual value like a few hundred right here, of course it's going to keep running. What happens if I hit the error 30? Then the timer bool will be false. And then after I clear the timer last time, essentially what we want to do is that we're going to skip this one because the timer bool is false, so that the timer actually stops being cleared every single loop. It actually starts some decent timing. so that what you see is that if it enters a zone, the timer starts timing itself. That's essentially what I'm saying. So that's exactly what I said. After the robot enters a certain zone, the sensor starts timing the sensor, or it stops clearing itself up every single loop, so that this thing, the timer will actually time in the background, and this thing will gradually get big all the way until it match up wait time, or the time we allow it to oscillate, and then it exits. And this, my friend, is the way I do the timing. And another little thing I want to add, actually two little things, I've got to tell you. Two little things that I want to add are, first, after you exit the while loop, what you always got to do is that you got to stop your robot, which basically means that if the last movement or the last adjustment, the value is not 0, or if you don't tune your PID loop well enough, and you don't have any actions after that, the robot might have a base power of 30. So you might see after this adjustment, the robot slowly drifting. That is bad. So after we exit the loop within this user function, we are going to stop the motor. So let's go move base. And this is essentially referring back to this user function we just made at the very beginning episode, move base 0. We're going to stop both sides of the base, which is essentially just stopping base. So this is the way you do the timer. Another issue is that because I do extensive amount of multitasking, and in future videos I am going to explain a lot about multitasking. If you have multitasking, every single command you do, they are going to be done in a round-robin fashion, and probably from this point all the way back to the after you clear timer, and then you compare you compare this timer to your wait time. Theoretically, it should just be a few. This should be done in an instant, not even in a millisecond. This from here to here should be done in a very, very short amount of time. But when your program is actually lagging, or you're doing some sort of multitasking, or when you forget to put a delay command in one of your loops, something might mess up, and you might end up having like 2 or 3 at this value when it really should be 0. When you just cleared it out, it just came back, it might have a little bit delay, it might pick up 1 or 2. So that you don't want to entirely make your wait time 0. You always want to give it a little bit wait time. Or actually, another reason for this argument is that you start timing after you enter a very small error zone, and you gotta give it a little bit time, right? Like a tenth of a second for it to actually hit the target, if you don't want any delay or adjustment, if you don't even want the effect of PID loop, but you've got to let it at least hit the target first. So that float wait time, and the reason I put float here is that I want you to know what you're dealing, so we are going to we don't have to every time we type 3,000 or 4,000. Although it's in milliseconds, it makes sense a little bit better than sensor readings, but I still want you to think in terms of 0.5 seconds rather than 500. So let's make another user function. Let's see if I have enough time. I might push this a little bit longer. Actually, I don't think I have enough time. So in this episode, I guess I will just call this it. I will make a follow-up improvement on this right here. Actually, flow this. I'll turn this into int. So the way I'm going to show you right now, you want to use it. If you don't want to watch the next video in which I will make this everything better, the way you use it is that PID-based control. You type PID-based control 12, and then you type wait time. For instance, in this case, we type 1,000. We type 1 second. What it's going to do is that the robot is going to move forward 12 inches, and after it gets almost to 12 inches, it starts timing, and it's going to adjust itself just with the P controller for 1 second, and then it's going to stop the entire thing so that you can move on to your next movement. So this is basically move forward 12 inches with 1 sec delay. And then we can, for instance, let's get another example, and then you want to back off. All right, great. Let's back off then. Let's say we want to back off 7.5 inches. So negative 7.5, 1,000. This is essentially back off 7.5 inches with 1 second.